Okay, so I'll start. Good afternoon. Hello everybody. So this talk is titled "Bringing Offline Voice Recognition Using Vosk to Automotive Grade Linux." This was done as one of the projects for GSoC, that is Google Summer of Code 2022. That is last year. So before starting and introducing the project and details about GSoC and the work done, I would like to introduce myself. So I'm currently a graduate student in robotics engineering at the University of Genoa, Italy. It's part of a program called Japan-Europe Master on Advanced Robotics. I've done my bachelor's in electronics and communication from TIET, India. My current interests, mostly academic, are in autonomous robotics, AI, and embedded systems. And I was the GSoC participant in 2022 with AGL. You could find me on this link, which should be there on the website. So, yeah, this is a collection of a few images, which basically shows all the things that I've done up to now, what interests me. So it's mostly a collection of hardware devices, wires, a lot of wires. You could see ROS right there, which is a sort of a software system for robotics applications. You could see some simulation running there. So. And in between, you could see me and Boran as well working on, he's here, working on Formula Student racing car. We were developing a data acquisition system. So from here I sort of got a spark to explore a little bit about embedded Linux. So yeah, this is one of those things that inspired me. So the agenda for this talk is basically covering about GSoC and AGL for which could help the future student contributors or first-time contributors to open source. Introduce my project and potential future plans. Some of the work which is still in progress, things like that. And finally, I'll be sharing some of my personal experiences to contributing to open source as a beginner. All right. This slide I included just to cover two main important things that I think are necessary for this project, which are recipes and layers. So recipes being the logical units of software. It's one of the most important part as far as Yocto is concerned, and majority of my work in GSoC was writing these recipes to get the final image built with all the dependencies, and of course creating a layer containing all these recipes. Yeah, Google Summer of Code. What is Google Summer of Code? It's a program run by Google every year during the months of summer. It's targeted towards young open source contributors, which used to be students before, but now it includes both the students as well as working professionals who are new to open source. It takes place usually in between the months, during the months of June, July, and August. And usually the contributors start working in the months of June and July. So my project was, my GSoC project was titled An Offline Voice Agent for Automotive Grade Linux. So I was mentored by Jan Simon Miller and Walt Miner from the Linux Foundation. So my project was the long project. So, and even now I am still working on a few things. So, yep. So the deliverables of the project were to create and configure a custom layer for an offline voice recognition agent. The layer is called Meta Offline Voice Agent. You could find it in the git.automotivelinux.org. And integrating them with the existing AGL layers. Using Vosk, which is a toolkit for offline speech recognition, and getting it to AGL, using it for speech recognition tasks. Then the next deliverable was to create and test a demo application, which is currently in Flutter. We also tried Qt, C++, and Python. So this app uses this voice agent, and it's a proof of concept. It's still in progress. And finally, to document the implementation and procedure, so I've maintained a blog which contains all of the details, the challenges, build issues, and the work done. It's documented on the blog, which is there in the link. So why did I choose this project? As I said before, I got some of the motivation from working on Formula Student car, and also I found this project to be quite interesting, which was there on the GSoC page of AGL Wiki. I wanted to explore the world of embedded Linux, and then talking about some of the utilities of this kind of voice agent for smart vehicles. It's very beneficial in reducing the distraction. It's good for it's quite convenient, and it increases the safety. And of course, talking about Vosk, it's multilingual. It has the availability of different sorts of models for various languages and dialects. So it's a really good tool. So before I start to talk about Vosk, I would like to talk about the engine, or the thing that powers Vosk, the concept, which is ASR, or automatic speech recognition. So it's a technology that enables a computer to recognize or transcribe spoken text or spoken words into text. So the main steps involved, as you can see in the diagram, are representing the signal, doing some pre-processing, using some of these models to do the recognition, and finally combining all the outputs and results together. So if I go into a little bit of detail, pre-processing step involves removing the noise, distortions, and enhancing the signal. Then comes the feature extraction point, wherein we extract the features from the signal, and then using these models, acoustic models, for getting for recognizing the phonemes from the signal, and language models for correlating the different words spoken to finally combine them to a thing which makes sense, a text which makes sense. So I think that should be all. So Kaldi is a toolkit for speech recognition. Now, why am I talking about Kaldi? Because Vosk has its own custom version of Kaldi, which it uses for its applications. Whereas Kaldi is mostly meant for research purposes, Vosk is more for real-life applications, real-world applications. So you can know about Kaldi on their GitHub repo. Now coming to the actual tool that we have used. So this is Vosk. It's an example which is Python based. It's again present on the GitHub repo. So it's a simple script, a standard script which they provide. You can run them, and this is so since the logging was enabled, this is some of the things that for now we can choose to ignore. And yeah, this is the output in real time. So what's happening is I was speaking something on my microphone, and Vosk was transcribing my words in real time, and it's appending all the results after certain timestamps and displaying it for the user. So what is Vosk? It's an open source toolkit that provides state-of-the-art speech recognition capabilities. The most important thing is that it works offline. So, well, we don't need internet. It's a very good speech recognition system. Can be used in a lot of places, chatbots, smart home appliances, and in cars. That's what we are trying to do with the help of this project. It's based on the Kaldi SR project. As I said, it uses a custom Kaldi, Vosk/Kaldi. The license is Apache 2.0, and this example was run by just quickly installing using pip install, because it was a Python package, and you can run it and use it in your applications. So it's pretty easy to use. It's offline. It has bindings available in numerous programming languages. And yeah, it has language models available in a lot of different spoken languages and dialects. So the best example is that for English it has I think two models. So English US and English Indian, which is trained on Indian data sets and so on. So it's quite diverse. It's scalable, so it scales from small embedded systems like Raspberry Pi to Android devices, iOS devices, or to big clusters. So and yeah, as I mentioned before, models available both in big and small size. We'll see about the models in a few minutes. And this is the change set that was submitted after doing all the work, basically enabling the layer, adding all the recipes. So we'll see all these things one by one now. Yeah, so as you can see, this is the structure of the layer. It contains all different sorts of recipes. So for example, this is one of the dependencies for the Vosk library. These are the Python recipes for Vosk API. So all the Python-based dependencies are there. So these are the created recipes. Some have been imported from the Open Embedded Layer Index. These are Vosk-specific recipes for the library, for Kaldi, and so on. Yeah, so the Python-based recipe. So I created these three recipes for the Vosk API to work. These are all the dependencies starting from SRT to sound device to CFFI, TQDM, and Pi audio. So yeah, it uses Pi audio for the all the audio requirements. And yeah, the dependencies below were found from the Open Embedded Layer Index, and were used in the recipe. So yeah, we can see that Yocto is quite flexible, quite easy to use once you know how to use it. And yeah, so yeah, this is again very important, adding all the voice models. So Vosk provides two types of models, big and small. The small models are typically 50 megabytes in size, and in runtime 300 megabytes typically. The models allow dynamic vocabulary reconfiguration, and we created eventually recipes for models in all these languages. And finally, we had a successful build and run for Vosk API and models. But Vosk API is not the only thing that would solve all of our requirements, because we want to serve these functionalities onto something, maybe for some applications. So we needed a Vosk server. So this is the server, which is again provided by provided along with Vosk. It's present in a separate repo, and this is a very useful server because it provides implementations in WebSocket, gRPC, MQTT, and WebRTC. It's quite useful. Again, easy to use. They have provided all the examples, example scripts. So for this, we created this recipe, vosk-server git, which is basically containing the stuff about the WebSocket server in CPP, Vosk WebSocket server in CPP. So this was created to serve as a backend for the demo application, or yeah, this is how it looks. Just you can see that. Yeah, it depends on Vosk model, a virtual Vosk model. So yeah, this is how it looks. We need not go into the details. So to make this work, we created these different recipes, which is Vosk OpenFST, OpenBLAS. These two are basically mathematics libraries which are necessary for the models to function. Kaldi, which is required by Vosk here, by Vosk library, and this library is used by the API and the server. So this was a little problematic. We had to do a lot of patches to make it work, essentially because in the Docker files for which define the build procedure, they just build it for x86 platform, but we had to modify it to make it multifunctional and to be able to work in different environments, so multi-architecture proof. Yeah, this is the Vosk server repository. If you want to have a look, you can visit this. So for testing, so once this recipe was built successfully, what I did was to import the AGL demo platform into my own system, and by using QEMU, I ran the image on my system. I used the standard script provided with Vosk to test it in the AGL environment, and it pretty much functioned. We'll see in the next slide. For the demo, I used this audio file, which is already provided with the script, and we also tested it with the microphone input along with the audio file. So both were working, and yeah. Yeah, this could be a little small, but what we are doing here is yeah, running the server and using this model which is already there in our image, and what we get is an output very similar to what I showed in the beginning, but inside the image right now. So yeah, this is the audio that was there. If I can play. Oh, it's not. Anyway, the person is saying the same words as we can see. And yeah, this is all the important parameters that it displays along with the partial outputs. So the scores, the start and end timestamp, the actual word, and then the final text, which combines all these words together. Yeah. This is something about the feature templates. So we created this to make our work a little easier, to be able to build an image with just the requirements for the voice recognition agent. And finally, we added ptest as well. This ptest was added to test the Python Vosk API with 3 simple lines here, and the test was successful in the end. We got the output. There were no errors as such. and then and then I submitted the patch for enabling this layer. So this includes this concludes the layer which has all the dependencies for Vosk to work. The scripts are running, but the thing is, do we have an application? Well, it's in progress. There's already an application already created, a very simple demo application. The backend that I used is a custom script that I wrote in Python. It uses gRPC protocol, and for recording, we are currently using a slight workaround. We are using GStreamer to record audio. Once the user presses a button, then the recorded audio is sent to Vosk for transcription, and the output is displayed. So it's just a proof of concept, but it's useful. And this is how it works. So you press the button, I speak something. Yeah, and it displays some output, so it's not very accurate, probably because the audio quality is not very good, or maybe because of my accent or something. But yeah, it displays some output in the app, and we have to integrate this, and we are doing that right now. So it's included in the future plans. So yeah, this is a very simple demo app. We could add a lot of improvements to this app. We could add a lot of functionalities, like we could work this for the infotainment system. Use this for infotainment system, like changing the volume or tracks, or for controlling the car temperatures, or for navigation. And finally, once all these things are done, we need to add the AGL documentation for this layer. So for now, just the blog is the only thing where all these things are documented for review. So finally, as a GSoC student, I would like to discuss some of the challenges that I faced and some of my learnings. So initially, there were some build issues with Yocto, and they were eventually solved, and yeah, it was a good learning experience for me. My mentor Jan Simon helped in solving all these issues. We had weekly calls where we discussed the roadblocks, the updates with other GSoC students who were working on other projects, and this was also extremely helpful. Yeah, the other point was that Gerrit was a little confusing, but initially, but well, once I learned, it's quite useful, and learning a lot of technologies in a span of 2 or 3 months, like Yocto Project, Flutter, Qt, and gRPC, and all these things. It was a little difficult, but it's a great learning experience. And finally, yeah, I had to relocate from India to Italy mid GSoC. So I got a break in between, and then I got a chance to continue on the project. So yeah, great support from the mentors. And finally, I was able to complete the project, and we could make it work. Thank you. That would be all. Any questions? Sorry? Oh, Whisper AI versus. I've read on a few blogs that Vosk is a little more simpler, and it was more accurate. So yeah, I think that was good enough reason. Yeah. Yeah. Right. Oh, is that all? Okay. Link to project. So it's basically present in the git.automotivelinux.org. If you go into meta AGL devel, it's there. The layer is present there. So name of the layer. And I will also include a link. I will upload it in the on the website. But yeah, this is the name of the layer. Um, yeah, and yeah, the blog post contains all the links as well. So um, yeah, okay. Thank you.